In this, the first of 4 eccentricity calculations, we're going to look at the situation depicted here, where we're unable to set up at trig J, so we have set out at an eccentric point over here, point E, and we observed J, Q and M. These are directions at this stage, although not necessarily orientated in terms of bearings, but they are generally facing north, as it turns out. So just looking at what we have here, we have got a direction here and a direction here, and the known distances between the trigs here. So first thing we're going to try and find out is, or what we would need to find out is this angle here. So that is unknown. We do have a direction out here and a direction out here, so we can determine that angle. And we have a distance here and a distance here. So we want to find this angle here, the angle at M. So it looks to me very much like we have a situation where we need to use the sine rule, where we have A over sine A equals B over sine B. We usually put these in capitals. I'll just erase that little one there. And we'll make that a capital A, which is the usual convention. So it's A over sine A, where A is the distance and A is sine A is the angle. So here's the distance that we have here, which is 6.47. And that's over the angle opposite that is the one we want to find. So that would be sine, I'll just call it question mark at this time, this point here. And that equals, now we'll just calculate this angle here. The easiest way to calculate the angles is to get them all going in the same direction. Now if we try and calculate around this way, we've got to go through the 360 degree mark, so it's good to have everything going in the right way. So to calculate that angle there, we can just flip these bearings around, so that becomes 145 degrees 0 minutes. 1 and 4 is 5, 3 and 2 is 5. There's always a good check on this. 32 degrees 30, that would become 2 degrees 30, just making them 180 degrees opposite. And so that angle there would be equal to that one there. And now we can take them away. Let's just do that over here. 2 degrees 30 minus 145 degrees 0 30 there. 5 from 12 7, carry the 1, 5 from 11 is 6, the 1 there, 67 degrees 30. Let's just do a quick check here by adding them up. 30, 7 and 5 is 12, 6 and 4 is 10, and 1 is 11, 2 degrees 30 minutes. So that's all checked out, and this is the angle that we need here. So B would be 6, 2, 628.49 and over sine 67 degrees 30 minutes. So just carrying on up here with that, we can see that sine 67 degrees 30 minutes times 6.47 equals 6285.49 times the sine we want to find. So if we were now to just divide both sides of this equation, 6285.49, if we divide that by that and put this all here over 6285.49, we can see that that enables us as 6285.49 divided by itself as 1, so that gives us, and I'll just put it round the other way, so we can get question mark will equal the inverse sine, sine to the negative 1, and we'll just put this in one big bracket of sine 67 degrees 30 minutes times 6.47 all over 6285.49, like that, and that equals naught degrees 3 minutes and 16 seconds. So we can therefore, from that, we can determine that the bearing of this line, or the direction of this line here, would be 32 degrees 33 minutes 16. Now there is a good way of checking this, a very good way of checking this, because we have the opportunity to use AutoCAD. We can actually draw this scenario to scale and then check it off with a accurate interrogation of our scale drawing. So what we would do if we were going to do that is we would start off here at the eccentric point, and using perhaps AutoCAD we would put in a line at 325 degrees for 6.47. Then from the eccentric point what we would do is we would put in a line of maybe 10 kilometers on that bearing of 32 degrees 30, and out this side here we would put in another line of say 10 kilometers, 253 degrees 45. Okay, then having at the other end of the line, what we would do is we would draw a circle with the radius 6285.49, and then where it intersected this line here, that would be trig M, and then we could join a line between there and that intersected point and check off what bearing we got. And I have done this, and I can tell you that I, using AutoCAD, got 32 degrees 33:16. We can also then, having this out here, it would pay to erase the first circle and draw another circle here with a radius of 6653.63 and see where it intersects this line to determine trig Q, and again join a line from here back to here in AutoCAD, and that will give us the bearing of this line here. What I am going to do now is I'm going to just calculate this line, this angle in here. This is the, I'll just do this in green. So to find out this one, we need to find out the green angle in here. So what I'm going to do next is I'm going to calculate what that angle is, and then from that determine this bearing here. I'm not going to do the working for that. I'm just going to present you with the answer so that you can do that and check how you're going based on the information that I've given you here. So it's just the same thing again, except you're using the sine rule. There will be a slight difference in the way that the angle is applied, and there may be some differences in the way we determine this angle here. But I'm going to go away and do that. Perhaps put the working here and then come back. And here we are. We have completed the calculation. Just followed through a fairly similar process to here, and we've got 0 degrees 0310 for the unknown small angle in here. Just note I've put the calculation here because it's subtracted from there to get this direction here. It's going to be less, so I've taken that away there and got 253.4150, and I can confirm that these are the same results that we got using our AutoCAD, so I can give that 2 ticks, and I'll also give this one here 2 ticks as well, because I have confirmed the answer using AutoCAD. And there you are. We have the first eccentricity calculation, 1 of 4.